Hello, I love this one. I can get a lot of really good info in all in this one situation, but there's a lot of parts to this one, so I'll probably break it up into a couple of videos. So it's a fairly simple function. We have this formula right here, f of n equals 3 plus 12 over n. It is a rational function. I know that because there's a variable in the denominator. There's a little more to it, but that's a good hint. It needs to have polynomials divided by polynomials only in the fractions, but this does count. And this function inputs the number of trials a rat has run through a maze and outputs the amount of time in minutes that it takes the rat to complete the maze. So inputs which trial it is, outputs how long it takes. Okay, and I have two things going on. I named it f of n up above, and then I have basically the same formula, but I've just changed the name of the function to g and the variable to x. And what I want to do here is just a little bit, I'm not going to get too crazy, but a little bit of compare and contrast between the real world context and just the function all on its own without any context involved. So if I'm looking at the function g of x here in part A, when it asks what is the domain, that just means what is the physical domain? What can you possibly plug into this function? It doesn't ask anything about rats. There's no context. So just looking at this function, what do I need to worry about? And the answer is for domain, we need to watch for square roots of negative numbers, division by 0, logs of 0 or negative numbers, and some of our trig functions, in particular tangent is one we'll see, does have some domain problems as well. It has some asymptotes. But here, there's no trig functions, there's no radicals. The only one I'm worried about is division by 0. So what I would say is that the domain is all real numbers except 0. I'm totally fine with being somewhat informal about this and just saying x cannot equal 0. Just know that if you say that, you are implying that absolutely everything else works. So if you don't want everything else, you'll have to specify. You could also write this other ways. You could say x is less than 0 or x is greater than 0. You could use some interval notation and say negative infinity to 0 combined with 0 to positive infinity, just leaving the 0 out by using round brackets instead of 0 brackets. So I'm really happy with any correct mathematical notation. So please make sure you're comfortable with a correct notation, but I'm not picky about which one. Okay, and then B asked me to sketch a graph of G. I'm really hoping you're coming out of some pre-calc with pretty good knowledge of graphing rational functions. This one is fairly straightforward, so I don't think it should give us too much trouble. If you think you need some review on that, let me know. I can find it for you. But here, what I would say is you could graph it in this form by thinking transformations. So I could think about taking the 1 over x function, which looks like this. And what I see there is I've multiplied by 12 to get the 12 in the top. So that's a vertical stretch by 12. So it's a much taller stretched out version. And I've shifted up 3. And that I think is the really big one here, because shifting up 3 will move that horizontal asymptote that was at y equals 0 up to y equals 3. So this has a horizontal asymptote at y equals 3. It should still have a vertical asymptote at x equals 0. We haven't done anything that moves that, but we did do the stretch, which will affect the points quite a bit. So you can snag a point and kind of see what happened to it. For example, the point 1, 1, if we do a vertical stretch, it'll end up at 112, and then we shift up, it'll end up at 115. That doesn't fit on my graph, so let's see. What if we try 4? If I plug in 4, I get 3 plus 3 is 6. So 1, 2, 3, 1, 2, 3, 4. So it should go through, goes way up there, and then it comes down, and it goes through 4, 6. And then we should have something fairly similar on the opposite side. This and getting pretty far off the graph fairly quickly. So that's rough, but I just wanted to kind of get the idea. If you need to use a graphing utility, I highly recommend Desmos. So let me switch over to that and we'll just double check ourselves. Okay, so here's desmos.com, and for graphing purposes, you can just hit graphing calculator, and in fact, you can use it as a regular calculator as well. You can type in calculations here, and it will do them, but we just want to type in our equation, and we can even use the function notation if you want to. You can use y equals, or you can call it g of x, and we had 3 plus 12 over x, so you can just type that in. If you have any trouble finding, for example, like your fraction bar and stuff, you can come in here. It has some pre-formatted stuff for you, so the division would give you that. Functions will find your trig functions and other things, so play around if you're not comfortable with Desmos. It's wonderful and it's free. Okay, so there's my graph. One thing Desmos doesn't show me is exactly where that horizontal asymptote is, but it looks pretty good, like 3 should be right. I was claiming that I should go through 4, 6, and that looks pretty spot on. You can just click and drag that around and see some points. It also looks like I crossed the axis at -4, 0, so I could even go add that detail back into my graph. So this is -1, 2, 3, 4. 0. Okay, so that's what function g looks like. And now I just want to think about the rat situation again. So that's the only reason that I'm calling this f of n and g of x, is just so I can say, okay, if it was just a function on its own, what happens? If it's f of n, what happens? And the answer is, I don't think the domain should be all real numbers except 0 anymore. I'm talking about rats. I shouldn't have negative numbers of trials. And in fact, I shouldn't have like decimal numbers of trials. I should have positive integer numbers of trials. So what I would say is you could write that out in words. Let's see, there are some symbols. You don't have to memorize them, but you can. So z is the integers, and if you only want positive, you can put a plus on that. So only positive integer values make sense for f. I suppose at some point we would say, well, they're not going to do an infinite number of trials, but we don't know exactly where to cut that off. So we generally just say, okay, we're going to let it get bigger and bigger, and know that a rat doesn't live long enough to do an infinite number, but we don't have a specific cap. Okay, so there's a difference between just the domain of the function and the domain in context. You have to think a little bit harder if you're doing domain in context about what makes sense. So it's really only this chunk of the graph that makes any sense. And even that, we would probably just want individual points, right? So if I was to graph function f, I would say, okay, what do I have? I have 1, 15. And then I would have 2, 9. I'm just plugging these back into either formula to get that. So 2, 9 drops down a little bit. I have 3, 7, 4, 6. And so we would just have a collection of points going along. We wouldn't even have connected dots. But often what we'll say is the continuous function is close enough. We understand that we won't use the individual points, and we'll still draw that full curve in there.